Hey, fellow mathers! Welcome to the podcast where math is figure-outable. I'm Pam Harris, a former mimicker turned mather.
And I'm Kim Montague, a reasoner who now knows how to share her thinking with others. At Math is Figure-Outable, we are on a mission to improve math teaching.
We know that algorithms are amazing historic achievements, but they are not good teaching tools because mimicking step-by-step procedures can actually trap students into using less sophisticated reasoning than the problems are intended to develop.
In this podcast, we help you teach mathing, building relationships with your students and grappling with mathematical relationships.
We invite you to join us to make math more figure-outable. Ta-da. Hey, Kim.
Hi.
Hey.
I'm loving what we have planned.
This is fun, right?
I
Today's
know,
gonna be fun.
Yeah. So one of the most popular series that we've done on the podcast at all, maybe, is about multiplication facts. We did I think it was like a 5-part series quite a while ago. And probably because it's a big ask for a lot of people, spans quite a few grade ranges and lots of people want to know more about it. So I'm excited about today and what we get to share. And, you know, I was actually Googling a little bit and I ran across a blog article by Tad Watanabe, who
we like Tad. Good guy.
He has some really thoughtful blogs. And I knew that we were going to talk today about stick and split. And his blog was all the way back from 2022. And he talks about an article that he read. And he said in his blog, I believe Pam Harris once tweeted about the app, but I really didn't think much of it at that point. I just don't pay too much attention to computer games and apps that are often promoted to somehow magically support students' learning. I should have paid more attention since it was Pam who was recommending. And then he talks about how he did go to the link. I agree, Tad. I spend almost no time putting a lot of attention towards computer games and apps. And then when somebody says, no, really, it's great, I'll look at it. And more often than not, I'm super disappointed. But we are excited about Stick and Split. So Pam, why don't you start us off? Because you found Stick and Split, or it found you somehow. How did you?
Well, first of all, thanks, Tad, for saying that about if I recommended it. And I actually tried to make that real. Like, I don't recommend stuff and unless it's actually good.
Yeah.
I am trying to think. I think the very first time I met David Tim, I think he poked me on Twitter. I'm not actually sure. I know we got on a Zoom. We chatted a little bit. He gave me a login. I checked it out. I was instantly interested. It was different than anything I had seen before. Wasn't like it's just not like any other kind of app I'd ever seen.
Yeah.
And then at least a year later, maybe even a year and a half, I was I'll stop trying to guess. I had the opportunity to present at a conference at Oxford, and that was an amazing experience. Had a really good time. And he met me for lunch. And actually I met a group of really wonderful educators. We had a nice chat for a good hour, mathematics teacher educators. And then David took my husband and me to dinner, and we just had a delightful chat. He is a parent who has been trying to create he also codes, and he's a technology guy. And he also, he's been trying to create an app for his kids to help them get better at multiplication facts. And he's been doing it for years. And it wasn't until COVID hit where he kind of had some time where he was like, well, I'm going to dive in and try with my youngest. So with my youngest, let's see, he had some older kids that he had tried before and just really hadn't ever found anything. And he decided to take a different approach than he ever had before. And instead of taking what he called, I think, something like a factor approach, which I think is what most of us do, he decided to take a product approach. So let me describe that just a little bit. He said instead that typically what we do is we say, all right, everybody go learn your 2s. Then learn your 3s, then learn your 4s, learn your 5s, learn your 6s, practice your 7s. And so that's kind of a factor approach. So you like 7 times this, 7 times that, and kids kind of practice those. I remember my daughter practiced her 7s, and then would go and take a test at the end of the week. And if she got enough of them in a certain amount of time, I'm not advocating this, by the way. If she got enough of them in a certain amount of time, then she got the scoop on her sundae or the toppings or whatever, blah, blah, blah. So typically we tend to approach multiplication facts by sort of practicing the factor. Well, he said, what makes up a product? And that's a little weird. So maybe we'll kind of talk about what the game looks like a little bit, and then we'll kind of come back to this idea of having a product approach. Okay. But instead of thinking about like the 7s, he said, let's think about like 12. What makes up 12? How can you think of all of the factor pairs that make up 12? And he does it in a really visual, spatial kind of way and in a fun game like kind of way. And he's very thoughtful about how he does it. And I think I've watched several kids play this. I've played it, and I watch kids just dive in and get kind of intrigued. And I think it does a really nice job. So let me just start off. If you start playing the game, so again, it's called Stick and Split because you can either stick numbers together or you can split them up. But importantly, you can only stick the same number together. So like if you have a bunch of twos on the screen, you can stick those together, but you can't stick a 2 with a 3 or a 2 with a 5 to make 7. You'd have to stick a bunch of twos together. So with twos, you can't make 7 because you can't stick twos together to make 7. Or you could split up a number. So if you had 8 on the screen, and they're all shaped like bars. So it's kind of like, it kind of almost looks like Tetris, where there's these horizontal bars on the screen and they are proportional to each other. So a 2 is smaller, is half the size of a 4, and a 5 is bigger than a 4 but smaller than a 6. Like, so there's these sort of horizontal bars on the screen. And so let's say you have a 6 on the screen. You could split, if you click on the 6, the bar that has a 6 on it, if you click on that, you could split it into 2 3s or you can split it into 3 2s. And you don't really know that when you click on the 6. It just gives you a stick. You have the option to stick it with something. You'd have to click another thing to stick it together. Or the split then just gives you where you can split it up into one way or another way. And it gives you both options, but it doesn't really tell you how. You just kind of have like a picture of, in fact, I'd have to actually pull up a 6 to see what the picture looks like. I don't have that up in front of me, but it kind of, you have two options. You can click on either the split it into three twos or 2 3s. Anyway, it's probably more than you kind of want to know. Let's get out what the game looks like. So when you very first start playing, the very first level is one of the only times you're ever going to see a 1. And so the very first level, Kim, if you started playing, and I don't know if you could hear it because the sound effects are on. I'm playing it on my phone right now. It says 4. So you're trying to make a 4. And there's a whole bunch of bars and they all say 1 on them. And so you can literally drag your finger across the ones until you put 4 ones together and you stick those and they line up next to each other and form, and they go all the way across the screen. Once the ones line up to each other, then they make the longer 4. And so it's 4 times as long. And now you have still a whole bunch of ones, but now you have 1 4. And then you can continue to stick those together. And I just stuck 4 more. And then you continue to stick them all together until you've made 4s. The bar of 1 doesn't show up very much more after this. It's a couple more times it shows up, but after this, it's much. Now you're going to have like 2s. So for example, the second level, if I were to go, I'm skipping now, to create 4s, has 1s and 2s. So you can stick 4 1s together. You click on the 4 1s. You can stick 2 2s together, and you do that, and you make 4s. When you're in this level of making 4s, there's also a diamond. And the diamond, if I click on it, is like that's like, you want to be special? So it says win a diamond, complete this level in 6 moves or less. So you have a whole bunch of 1s and 2s. So one way that you could do that is you could put the 1s together to make 2s, and then the 2s together to make the 4, because the total is 4. But then it might take you more than those 6 moves, and then you wouldn't get the diamond. So you're trying to be kind of like efficient. So I'm sitting on this make a 4, Kim, and a message just appeared, and it says make a move for you. So it's kind of like the hint. So if you wait too long, or I guess not too long, but long enough, if you pause long enough, then it will say, hey, do you want me to make a move for you? And then it will literally kind of light up the little bars to kind of give you a suggestion of how you can move from there. I'm not going to have it do that for me because I'm going to move on to a more fun level. So I'm going to all levels and I'm kind of skipping ahead. So this is interesting. You could actually, let me come back to that. Kim, remind me later. I want to talk about kind of how the levels are situated. So first of all, you make 4s. Then the next set of games is you make 6. So when you look at 6, to make 6, the very first level just has a bunch of 2s. So Kim, I know this is lame, but what would you do with 2s to make 6?
Put 3 2s together.
Duh. Okay, so you put a bunch of twos together. You put 3 2s together a bunch of times, and you get 6. The very next level has a bunch of threes. So how many threes would you put together to make 6?
2.
Right. So thank you for playing along. I have seen a little 4-year-old. I was looking over his shoulder while he was playing this, and he goes, huh, it was 3 2s made 6, and now 2 3s made 6. And then he kept playing. Like he just
Great.
like said it out loud. I don't know if he said it quite that, expertly, but he like noted that. It was sort of interesting. Then the next level, there's 2s and 3s. There's a diamond on that level that says to try to do it in whatever few is possible. Then the next level, remember, we're still making 6. So we're making 6. The next one says it just has a bunch of 4s, Kim. There's 4s. So I watched this kid try to put 2 4s together. And if you try to stick 2 4s together, I'm on that level, and I just dragged it over. The 2 4s are blinking, and I hit, oops, I meant to hit, I hit stick, and it says that's more than 6. So it won't let me put 2 4s together. It just says that's more than 6. So what can I do? Like there's these 4s, and I'm supposed to make 6. So the only option available to me at this point is to take one of those 4s and split it. So if I take one of those 4s and split it, it's the only option available. I think it's the only option available. And I split it. Now it shows me that I can split it in half. Like the little thing comes up, and so when I click that, now I can make a bunch of 2s. I didn't even realize until I was looking over this 4-year-old's shoulder that I can select multiple of those 4s and hit split, and it will split them all into 2s. So I can do it really fast and split all into 2s, and then I can put those 2s together to make 6. Does that make sense?
Yeah. Is there, for whatever reason, I wrote down 4 4s.
Oh, there was a
Are
lot more
there the
4s.
number of 4s that are equivalent to however many 6s you want to make? Like, is it leading in any way about, like you talked about it being equivalent.
Mm-hmm.
Um,
Mm-hmm.
I can't see what you're saying, but does it just give you a ton of 4s like on the screen and you just do what you want with a whole bunch of 4s? Or is it across horizontally the same length as anything else?
Oh, I'm not sure I understand what you mean. The 4s right now, if I split the 4s into 2s,
Mhm.
and I put 3 2s together, those 3 2s fit the total length of the 6,
Ah, okay.
which is
Yep.
taking the total width of the screen.
Yeah, that's what I was wondering. It's
Okay,
been
so
so long since I've looked at it.
yeah, so the total is this, at least that I can see, is the length of the screen.
Mhm.
And so you're trying to put things together to make that width. I say length and width at the same time. To make it's the total is the width of the screen, and so you're trying to put those. So like right now, I have 3 2s, and if I stick those 3 2s together, the 3 2s right now are making the total width of the screen. And as soon as I stick them together, I just stuck them together, then it's a whole 6. Now they turned
Mhm.
into there are a bunch of yellow 2s, and they just turned into one pink 6 that was the same length of all those 3 2s stuck together.
Yeah.
And then when you were asking how many, I can't see anymore because I've already split a bunch of them and stuff. But there were a whole bunch of 4s and 1 2, and I'm
Gotcha.
assuming that 1 2 is necessary to complete all of them together, so that at the end of it, I just have a bunch of 6s.
Yeah, that's exactly what I meant. If there's some sort of equivalence represented on the screen so that you're not left with some or looking for some amount
Mm-hmm.
that's not there.
Yeah. So the first time I was looking at this, I thought, it's fine. You stick these things together, and it hadn't really occurred to me the commutative property idea, where you can put 3 2s together and then 2 3s together, and a
Mhm.
kid can start to notice that. And I've watched kids notice that over time. It's amazing to watch them go. Like I literally heard the kid go, to make 12, you can do 2 6s, but you can also do 6 2s. Ha! It did it again. Like
Mm.
just really cool kind of commutative property thing coming out. But then I also, when I hit this level where it was try to make 6s with 4s, I was like, how do you do that? And it literally took me as an adult a minute to go, like, what am I going to do with these 4s to make a 6? You can't put 4s together to make a 6. Oh, you have to split the 4 into something that then you can create a 6 out of. I
Yeah.
thought it was really cool. Anyway, so then they have these diamonds that I also think is cool. So, Kim, one of the things I wanted to mention, I said a minute ago, was the levels. I think you could even, as an older student, step back and actually look at the levels. So, for example, the first thing that you try to do is make 4, and you do that in a couple ways. The second thing you try to do is make 6, and there are 5 levels to make 6. The next thing you do is make 8. When you're making 8, guess what the first thing is? First thing is a bunch of 4s. Okay, so put 2 4s together to make 8. Duh. Guess what the next level is? A bunch of 2s. So again, you get that commutative property thing happening. I can stick 2 4s together, but I can also stick 4 2s together. And I start hearing kids say things like, did you know 8 is made up of 4 2s? Did you know 8 is made up of 2 4s? Like they start they start taking a product approach. What is 8 made up of in terms of factors? And I think that's really cool. In that 8 level, you start with 4s, then 2s, like I just said. Then you have 2s and 4s. Then the next one is 6s. So, Kim, kind of curious, if you just saw 6s and you're going to try to make 8, I'm looking at it right now. I'll tell you there are 1, 2, 3, 4, 5. There's 6 6s and 1 4. You don't have to finish the level, but what would you start off with if you just had some 6s, but you have to figure out how to make 8?
I'd break up the 6s into 2s and then put 4 2s together to make 8.
Bam. That's fantastic. I think that's cool. The kids think about that. The next level has 2s, 4s, and 6s. So similarly, you'd break up the 6s and then put those together.
Uh-huh.
And then the last one has 2s and 3s.
Okay.
Any ideas what you would do with 2s and 3s to make 8?
I put some 3s together to make 6s and then break those 6s into 2s.
So you're making 8s, but you're also thinking about multiples of 3 and then factors of 6 to then think
All
about
to get to 8.
all to get to 8.
Yeah.
So kind of that product approach for 8. All right. So the levels so far have been 4, make 6, make 8.
Okay.
Why did we skip some? How come we didn't make 5?
Because
Or
it's a
7?
prime number.
Bam, right? So we didn't make 5, we didn't make 7. So after 8, what's the next one? Do you think we're going to make?
10.
We're actually going to make 9.
Oh. You said right after 8. That's awesome.
So we are going to make 9. We're going to make 9 from 3s. We're going to make 9 from 6s.
Yeah.
So we're going to have to split the 6s up, but that's not too hard, right?
Right.
But then we're also going to make 9 from 2s and 3s.
Okay.
So what are your thoughts about making 9 from 2s and 3s?
Can I make 2s become a 6 and then break the 6s into 3s?
Right? Isn't that cool? I think it's cool. I don't know.
Yeah.
I don't know how cool you think it is. I think it's cool.
Yeah.
Okay, so the next one's 10, and then the next one's 12. Now the 12 level has the most, or the make 12 has the most levels in it.
Yeah, which coincides with the fact that 12 has
a lot of factor pairs.
I
do. I do. Yeah.
And so then I went like, oh gosh, what's the 24 level and the 36 level and the some of those.
Ooh, nice,
really,
right? Yeah. So 12 has a lot. 14 just has a couple. 14 has, you can make 14 from 7s. I should have had everybody guess what you could do for 14. So the first thing it does is make it from 7s. So it's just 2 7s, right? You just put 2 7s together. What's the next level then? Do you mind if I
after 14?
Yeah. So making 14, the first thing you do is create it from 7s.
Okay.
What would be the next way you would make 14? Just if you were to
2s.
guess. Yeah.
2s,
So
I think,
put 7 2s together. Then you're going to make 14 from 6s.
I have to write that in. 14 from 6s. Okay. Yeah. To get to 2s, to get back to 14s.
So because 6 you can get to 2.
Which is really brilliant for common factors.
What do you mean?
Like you're thinking about common factors from 14 and 6. To know that to know that 14 is 2 and 7, 2 times 7, and then 2 times 3 is 6.
Yeah, nicely said. So a lot of teachers of older students will say kids need to have their multiplication.
They got to make a list. They got to circle them.
Yeah. Or they'll say the kids have to have their multiplication facts memorized so that they can recognize the multiples. Or this is an example of how we can actually build the idea of thinking about common factors. And here's something else that David told me when he and I were talking in person. He's very clear that he is starting from he started from 4. So we're thinking about all the ways to make 4, all the ways to make 6, all the ways to make, and now we're 14, all the ways to make 15. Notice how we're focusing on this product approach with small products.
Yeah.
He said, if we take a factor approach, which traditionally I think almost everybody has, we're doing 2 times 9 immediately. Like we're in the twos, whatever doubles, whatever, and we're already at 18. Boom. Or 3, we're taking 3 times 9, 3 times 8. We're into 24 and 27. As soon as we get to 4, now we're into 38 and 38. 30. Try to do too many at once. 4 times 8, 32, and we're doing 36. Like we're instantly in these big numbers, even though we're in small factors. But his approach really gets you thinking about these small products well, like really breaking up 12 a lot, messing around with 12 in lots of different ways before you ever move to messing around with 14, before you ever move to messing around with 15. So I think that's also really intriguing that we get kids really good at these small products. And we're already thinking about some intense, complex ideas, like you just said, common factors, before the numbers get too big.
Yeah.
I think that's really interesting. Go
Well,
ahead.
and a lot of people say kids need to know their multiplication facts as they get older, and I would actually argue that one of the things they really need to know is less of the product of a multiplication fact, but they need to know, like, they're given the product and need to know factors much more often as they get
Mm,
older. And there's a distinction between the two, and I think he's hitting that with this game of
hmm
taking a product approach, because when you're factoring stuff in middle school and high school,
hmm
they're not asking what's 7 times 8. They're asking what is 56 made of.
Yeah, nice, nice. So one thing that I'll just mention is for every one of these makes, so like if I look at make 24, the very first move is the largest factor pair. So
Mhm.
from 24, you're going to get a bunch of 12s. And then the next move, you're going to get a bunch of, well, that's interesting. This is from 12. There's 2 from
6 and
12s.
2.
I don't know that I've played them both. No, there's 2 levels from 12s. Now it's making me look. So this one just has a bunch of 12s. Now I got to go look. What does the second one have? Maybe I'm reading this wrong. Hold on. The second one has a different bunch of 12. Oh, it has a diamond. So the first one doesn't have I don't know what I'm not sure what the
Is
difference
it
is
an
between those
actual
two.
diamond or is it a rhombus?
Oh,
Parallelogram.
it's neither. It looks like a diamond ring. It's
Okay.
not.
Oh, that's great. That's
It's like a
great. I love it.
pentagon. Is that a two? It's a pentagon. Yeah.
But it's a diamond ring. I'm here for that.
There you go. There you go. Thank you for clarifying on that shape. Yes. So my point is with 24, you're first going to mess around with 12s, and then the very next thing is you're going to mess around with 2s. And so that commutative property is
Yep.
just happening with every one of these guys. In 24, after you do 12s and 2s, then you do 8s, then you do 3s,
Yep.
then you do 8s and 3s, then you do 6s, then you do 4s, then you do 6s and 4s, then you do, are you ready for this? 16s. Oh, I love it.
Yeah.
I think he's so clever. So we're
Does
gonna
he do
what do
nines at all?
well after 6, so let's just for everybody 16s. How are you gonna get from 16 to 24?
Okay, wait. I gotta write down. We're going for 24,
Uh-huh.
and we have a bunch of 16s.
Correct.
Okay, then you're gonna break them into fours and put the
Oh,
fours together.
I put the fours together, and I was
Mhm.
gonna break them into 8s and put the
Okay.
8s together,
Okay. Will
right?
it let you break it into either?
Yes.
Okay. Cool.
Yeah, you have the option. Uh-huh.
Yeah, I love it.
So the next one is to get to 24 from 18s.
Okay. So sixes or threes.
Nice. Yes,
Yeah.
yes. And then the next one is 16s and 18s in the same one.
Okay.
The next one is 20s. So let's let
Okay.
everybody think, podcast listeners. If you have
Yep.
20s, how are you going to get from 20s to 24? Okay, Kim, what are you thinking?
I'm gonna break it into fours and fives and put the fours together.
So when you say 4s and 5s, you mean 5 4s because you're not really
Oh,
one
yes.
factor,
Sorry.
right? One factor.
I
Yeah.
wrote I wrote 5 4 on my paper.
There you go. There you go. Nice, nice. And then the last level for 24 is it gives you 2s, 3s, 4s, and 5s. A minute ago, you asked if it nines, I think. It does not ask from nines. But so
Maybe
maybe,
because it gets too many of them.
yeah,
Like at some
maybe we only
point.
need so many
Yeah.
24s. Yeah.
Yep.
Okay, cool. Okay,
So what's
so,
really cool is as you go up the levels, right?
mhm.
I'm kind of assuming it's like you're progressing with
Yeah,
the
yeah, yeah.
numbers. Within the 24, I had to think about the 20. So I'm reinforcing the 20 that I already did.
hmm
And because I'm within 24, he's using what you've already built.
Yeah, yeah, and, especially because he's using any of the factors of 24 we've already messed with.
Yeah.
Yeah, yeah. Cool. So the next one's 25s, and I wanted to actually ask you this one specifically. So in Make 25,
Uh-huh.
the first level is from fives. Okay, so you need five fives together. The second level is from tens. I don't think
Okay.
that's too big of a stretch. Split
Mm-hmm.
the 10 into fives and then put the
Mm-hmm.
fives together. The next one's from 20s. What are you thinking about from 20s? How would you get
So that's
25?
four fives. And put some fives back together.
Put some fives back together. The last one is twos, threes, fours, and fives, all in the same screen. Twos, three, fours, and fives. Threes. That's kind of weird.
Yeah.
What are you gonna do with the threes?
Do I have a bunch of threes or just a few? Like,
Let me get in
is
there. You've
I can
got
have as many as I want.
no, just
Okay.
only the ones on the screen. There's a lot, so I'd have to count. Let's see,
Okay.
2, 4, 6, 8, 10. There's 10 threes. You can't put them all together because that would be 30, and that's more than 25.
Yeah. So I
Yeah.
want something that is made of threes that's under 25.
Mm-hmm. That what? What are you looking for? Like, finish that sentence.
Something
Something.
that's under that's made of threes,
Mm-hmm.
a product under threes that is divisible by 5 also.
Nice.
So 15.
Nice. That was
Yeah.
well said. Right. That took me a minute to be able to verbalize
Yeah.
that I knew I had to do something with threes that in some way was going to get me to 25, but I had a hard time
Yeah.
thinking about what does that mean? Oh, I need to create a product that's divisible by 5 because I
Yeah.
want to get fives out of it.
Okay,
Right?
so I had to say right now, and I could wait till the end, but I'm just going to stop right now and say it. My apologies to David. I don't know if he'll ever listen to this episode. Maybe somebody can tell him. My massive apologies because I don't know. It was like 2 years ago, 3 years, whenever
Yeah.
you first saw it, and you were like, "Hey Kim, like, what do you think of this game? I'm really loving it." And I, looked, and to be fair, I didn't go, "Yeah, I hate it." I was like, "Yeah, I think I might have even said to you, yeah, I don't hate it." And I got my kids on,
Which is
and
typically high praise, but okay.
it's so I am judgy about techie things. I don't know why. I just feel like we spend so much time on them and it's waste. Anyway,
Yep. Yep.
so but I did. I think maybe he even gave us an account. Like, so kind. And I got my kids on it and they played and I was like, yeah, okay, cool. But I didn't spend any time. Like my kids are, because they're my kids, they're like not easily pleased by that kind of stuff. And you loved it and other people had loved it. And I was like, yeah, great. There's so much more depth than I think I even realized.
You're
Um,
realizing now. You're realizing now.
yeah.
Wow, that's
In
really
this
well done.
conversation, I'm like, wow, that's, there's so many layers to it. I want his brain like that.
Yeah,
That's,
nice.
that's really, really well done.
Hey, let me just say one more thing. So on this 25 level, it says make a move for you. I'm going to click yes. And I'm just going to
Okay.
tell you that it just, oh, see now that's funny. It did it so fast. I didn't see what it did. Ah,
Gotta pay
now
attention.
I would have to sit here for it to do it again.
No.
Yeah, let's not do that. So let me just mention really quick before we're done. After 25, then 27, 28, 30. But if I'm going to go all the way up to like 35, 36, 40, 42, 44, 45, 48, and 50. In the 50, there's a level that asks, how do you make 50 from 40? Which I just throw that out. Like, and one of them is from 45. So just kind of be like listeners, hopefully you're intrigued at this point to just go,
Yeah.
whoa, like how would you do that? Y'all, I'm scrolling. It goes all the way. Can I even get all the way to the end? It goes all the way up to make 200 is the last one. Make 144, make 132, 121, 120. Anyway, I think it's fantastic. David, I think you're onto something. Y'all, if it were me, I would have this on my phone. I think it's $2.99, stick and split. If I was a teacher, I'd have the classroom companion thing, whatever. I think you can do unbelievably amazing things with this. I would recommend it over and over again. I
You
think
just recently did.
and I did actually. Yes, I had just had an ultrasound the other day, medical stuff, whatever. And the ultrasound tech was asking me, what do you do, whatever. And I said, she said, what can I do to help my kid? And I said, put stick and split on your phone. Absolutely, do it right now. Your kid will love it. It'll be fantastic. Play it with them. Talk about it. All the things. And I also suggested number hive, which we are going to talk about in our next episode. Yeah.
Yeah. Hey,
All right.
we're in Texas, and we are either on or close to summer break in schools. And parents ask you, teachers, it's a great time for you to check it out. There is a single user app, and there's a class package available. If I were in the classroom right now, I would be writing some fantastic questions to go along with the time that my kids were spending on the app. There's so many things you can do with it. So check it out. Let us know what you think.
Fantastic. Thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com and keep spreading the word that math is figureoutable.